Hey, welcome. In this video, we are going to learn about Matplotlib, one of the most powerful libraries for data visualization in Python. By the end of this video, you will be able to create your own plots and graphs, bringing your data to life with Matplotlib. Just a quick reminder, before we get started, make sure you have Anaconda or Miniconda installed along with Jupyter Notebook. If you don't have them installed yet, no worries. I'll leave the links in the description box and you can have them up and running in a few minutes. This video is going to be around 30 minutes and I won't go over every single features of Matplotlib, but I'll teach you the most important features to create stunning and informative visualization for your projects. So let's get started. Matplotlib is primarily a data visualization tool. So it's a Python library specifically designed for creating a wide range of visualizations like charts and graphs. So it's very useful because it allows you to see the patterns in your data. Okay, so you can see the patterns and trends in your data in a clear way or understandable way. You can create all kinds of plots like line graphs, bar charts, scatter plots, and even histograms. Okay, so in this video we will start by creating some of the simple plots and see how it can be useful for our stock prediction portal. So first of all, we will start by activating our Conda environment. So I'm inside my stock prediction portal and I will right click and create a new terminal, and my base environment is activated. I don't want that. I will actually say Conda deactivate. Okay, so the base environment is deactivated and I want to activate my stock env environment. Okay, so first of all, I'll say Conda env list just to confirm. Yeah, okay, so I have this stock env environment. I will activate it. Conda activate stock env. Okay, so this is activated and I'm gonna say Jupyter Notebook. Okay, my Jupyter Notebook is activated, opened, and I will actually create a new notebook and rename it to learn matplotlib. Learn matplotlib. Okay, rename. All right, first of all, I hope you have installed Matplotlib library already. If not, you can use this command conda install matplotlib. Okay, so otherwise you can also install using pip, like this, pip install matplotlib. Okay, you can also use that. Anyway, so matplotlib is already installed in my environment, so I'm going to import it. Import matplotlib. Okay, matplotlib dot pyplot as plt. So why this is dot pyplot? Because most of the plots are coming from pyplot module of matplotlib library. So that's why I'm going to say import matplotlib.pyplot as plt. So also I'm going to import pandas, because in the later section of this video, I'm also going to show you how you can create the plots using pandas and numpy. Okay, so that's why I'm going to import pandas as pd and also import numpy as np. All right, execute it by shift enter. Okay, so now we'll start creating some simple plots. Okay, so there are multiple types of plots this Matplotlib is providing to us. So some of them we will see in this course, because of course I cannot cover everything because Matplotlib is a very huge library. So first we will see the default plot type, which is the line plot. Okay, so we have line plots and we have bar charts and we also have scatter plots and histograms also we have. Okay, so after that we will again we'll have like pie charts and all that, but everything is not necessary in this course. So anyway, we'll start by creating line plots. First I'll say so first let's see how we can plot our line plot, okay, which is our default plot. So let's take a value x is equal to 1 2 3 4 5. Okay, so this is just an array or the list, and we will say y-axis, which is equal to again 10 20 25 30 40. Okay, so this is just the random numbers, and we have this x and y. We want to draw the plot using this x and y, so simply say plt dot plot. Okay, so when you say plt dot plot, it will draw the line plot. Okay, so x comma y, and hit enter, and you can see this is the type of plot you're seeing. Okay, if you're not using Jupyter Notebook, you will also have to say plt.show, so it will show the plot. If you're using Jupyter Notebook, you don't necessarily have to call this a show function. Okay, simply hit enter and you will see this kind of plot. So you can visualize the data here, right? We have 1.52 like this, right? So until 5, right? And we also have the y-axis. This one is y-axis and this is the x-axis, right? So the value you can see here 10, 15, 20, 25 like this. Okay, so one more thing, you see this object here, right? If you don't want to see this object like this, and you can simply add one semicolon here and put a shift enter. You will not see that. Okay, so just put the semicolon. Okay, so now you can also add the labels to this plot, right? How you can add the labels. For example, just by looking at this chart, we don't know what is what, right? So that's why we can specify the label here or the chart name here or the title like that. Okay, so we will add a little bit of customization to this. So once you're done with this plt.plot, you can also say plt.title to say which plot is this, right? So for now, I'm going to say simple line plot, simple line plot. And once you hit enter, you will see this, right? You just add the semicolon, then you will not see this kind of things. Okay. And you can see the simple line plot here, right? This is actually an image. Okay, I will also show you how you can save this kind of plot images as well. So this is the plot name now. And if you want to add the labels to this x-axis and y-axis, you can say plt dot x label is equal to, oh, I'm sorry, not is equal to. It is just open the parenthesis and you pass this x-axis label. Okay, x-axis label. And similarly, you just copy and paste it. So this will be y label, plt.y label, and this will be y-axis label. Okay, so this can be anything. In the future, I will show you how you can print the price and dates and all that. Okay, so we are just trying to learn this kind of plots. So let's see how it looks. Okay, again, you see, we are getting this kind of text and objects, right? Simply put semicolon and you will not see anything. Okay, so now you can see y-axis label and this is the x-axis label. What if you want to print the grids, right? So in that case, you say plt.grid equal to, grid pass true and hit enter and you can see this kind of things, right? So this is the grid line chart. Okay, so let's try to create one more type of plot, which is our bar chart. So I will say bar chart. So let's take one example. Okay, so instead of writing 1, 2, 3 like this, we will use one simple example. Let's try to visualize the monthly revenue of a sales or something, right? So in that case, what you do is, let's consider we have this months, right? So for example, we have all right, now I have 4 months data, which is the months and the revenue, and it has Jan, Feb, March, and April, right? So revenue is 100, 200, 300, and 400. Let me execute this and let me try to visualize this with the bar plot or bar chart. Okay, so I'll say plt dot bar. Okay, plt dot bar and pass this months comma revenue, months comma revenue, and hit enter and you will see this kind of things, right? So this is the bar chart and you can easily visualize this data, right? So imagine you have a lot of data like this, then it will be difficult for you to see which month you earned more and which month you earned less, right? So this bar chart will help you to visualize the data properly. So in the Jan, the revenue was 100 and Feb 200, March 300, and April it is 500, right? So similarly, you can also add the title, X label, Y label, and all that. I will just copy this. I will just copy this and I will put it here. And plt.title, it is actually a monthly revenue bar chart and x-axis. So what is this? This is months, right? So the x-axis will be months, and the y-axis, the label will be revenue, right? Now you can see, visualize it properly. Okay, so now what if you want to make the image bigger, right? We also have one more function called plt.figure, plt.figure, and you should call this plt.figure just before calling the bar chart. Okay, so and just say fig size. Fig size is equal to add a width to 10 and 6. Okay, so this will become a rectangular plot. Okay, now you can see the chart has become bigger, right? So simply use this plt.figure fig size. Okay, so after that, we also have one more type of chart, which is a histogram. All right, moving forward, the next type of plot we want to see is a histogram. So to visualize the range of data, we can use histograms. Okay, so what kind of range it is? Well, let's say we have 50 students in a class, and the teacher wants to visualize the marks of these 50 students, right? So we can use histograms to visualize these marks, right? So let's try this practically using histograms. Okay, so let's say we have the marks of 50 students, right? So marks 50, I will just create a variable, and I will create numpy array, okay, np.random randint, okay, randint. And so because see, I don't want to create the marks of 50 students manually, so that's why I'm using np.random.randint. So I will start from, this marks will start from 0 to 100, and I want the 50 students marks, right? So that's why I'm going to pass 50 here. So this will actually generate the marks of 50 students ranging from 0 to 100. Okay, so let's okay, just print it, marks 50. Okay, so you can see it has generated 50 records, right? So let's pass this 50 students marks to the plot. Let's say plt.hist. Okay, so when you want to generate histograms, just say plt.hist and pass this marks, and now you can see this is how the histogram is looking. Okay, so if you don't want this kind of things, just put one semicolon, and you see this is the one. So what you can visualize in this plot, right? So I will tell you, but before that I will just add plt.x label. Okay, plt.x label is actually a marks, right? This is a marks. So this one is marks, right? 0 to 100 is a marks, and plt.y label. What is y label here? It is the number of students. Okay, so this is the number of students. Okay, so now you can see it is number of students and marks here. So what you can visualize here is that 6 people or 6 students have scored 0 to 10, right? So this is what I said in the beginning. So the histogram is used to visualize the range of data. Okay, so you see the range here, right? Which is 6 students have scored from 0 to 10, right? So this one is 10 here, 0, 10, 20, 30, 40, 50, 60, 70, like this. Okay, so 6 students have scored 0 to 10, and 7, I think this is 7, right? 6, 7, 8. 7 students have scored 10 to 20, and again 5 students have scored 20 to 30. Okay, and again 5 students have scored 30 to 40, right? So you just imagine there is 130 mark here. Okay, so the teacher can also see the minimum number of students scoring a specific marks range. For example, you see one student, so this is one, right? So one student has the mark 80 to 90, right? So he's in the range of this 80 to 90 marks, and 90 to 100, most of them have scored 90 to 100. So based on that, the teacher will understand I'm teaching very good, or something like that. If most of the students have scored very less, then the teacher will understand that the students are not doing good at exams, or he needs to improvise his teaching skill or something like that. Okay, so this is how the histograms will help us to understand the data points. Anyway, we are not going to use this histogram in our stock prediction application, but still I just wanted to show you there is this kind of plots in Matplotlib also. Okay, so there's one more thing in histogram called bins. Okay, just want to show you what is this bin. Okay, because in futures, if you want to use this histogram for another project, then you should just know about this bins. It is very important. So bins are the intervals into which the range of data is divided. Okay, so each bin represents a range of values, and the height of the bar for each bin indicates the number of data points that fall within that range. Okay, so if you don't understand this definition, definitely I will show you how this bin works. Plt.hist, right? Plt.hist, again, just say marks 50 comma bins is equal to, let's start with 2. Hit enter. And so what this bins has done to this plot is it has divided the graph or divided the data points into two pieces, right? So 25 students have scored from 0 to 50, and 25 people have scored 50 to 100. Okay, so this one is not a clear graph, so it is just filled properly. I mean, both of them has 25. What I'll do is I will again hit enter, and now it has generated different marks, right? So I will just execute this. You will see the different graph here. Why different graph? Because I'm using random randint, right? So at this point, if you hit enter, and you can see here, right? So bins is equal to 2, right? So each bar represents the intervals. Okay, so for example, by default it gave us 10 intervals or 10 graphs, right? It divided the data by 10 pieces, right? But here we are using bins is equal to 2. That means it is dividing the data by 2, right? So here what we can understand is almost 30 people or 30 students have scored 0 to 50. Okay, so this is 50. Okay, why 50? It has divided 100 students marks into 2, right? 50 and 50. So almost 28 to 29 students have scored 0 to 50, and almost 20, I think 21 have scored 50 to 100, right? So what if I put bin equal to 5, right? Now you see, you can have the closer look at this, right? So for example, almost 12 students have scored 0 to 20, right? Almost 9 students have scored 20 to 40. Almost 16, or I think, yeah, 16 students have scored 40 to 60, right? So that's why you can use this bins to see the data or see the visualization clearly. Okay, so that's about histogram. And we also have this scatter plot. So I will say scatter plot. So for example, I will take one example for scatter plots. So for example, I want to visualize the height and weights of a person, right? So I'll say person with a 65 height, and 70 is the height, and we also have 68 height of person, and the person with the height 72 and 66. So let's say this is the height in inches. So let's consider this is actually the height of a person in inches, and we also have the weights is equal to, so let's say the person whose height is 65 inch, his weight is 150 pounds, and 160 pounds, similarly 155, 180, and 145 or something. Okay, so this is actually the height in inches and weight in pounds. Let me execute this, and I will plot a scatter plot now. Okay, so plt dot scatter, and into the scatter function just pass heights comma weights, and you see, this is how we visualize the data in a scatter plot. Okay, so to make it a little bit clear, I will use plt dot title heights versus weights scatter plot. Okay, you can give any title here. plt.x label height in inches, and plt.y label weight in pounds. All right, so you can see this is how we visualize. What you can understand from here, that each data point on the scatter plot represents an individual's height and weight, right? So this point is indicating the height of a person, which is 65, has the weight of 150 pounds. Okay, and another data point here, it is saying the person whose height is 66 inches has the weight of 145. Okay, so you can also recognize the pattern here, right? Just by looking at this plot, you can see that there is a relationship between height and weight, right? In this case, the taller person tend to weigh more, which might indicate a positive correlation, right? Similarly, shorter person tend to weigh less, right? So these patterns we can understand using such scatter plot. So let's go a little bit deeper side of Matplotlib, which is you can also create subplots, and we can add the legends, right? So for example, I will teach you how we can add the subplots and how we can add the legends, right? So it is related to the project that we are building in the next section, which is the stock prediction, right? So here I'm going to say subplots and legends. All right, so let's take an example of the stock or trading days. Okay, so for example, in a week we have 5 trading days, right? So I will take days 1, 2, 3, 4, 5, right? So just consider this is the trading day. Okay, in a week we have 5 trading days, right? So let's say we have the original price. Let's say we have the original price, maybe the stock moved from 10 to 20, from 20 to 25 to 30 to 40. Okay, and then we have predicted the price as well. Predicted price. So this is the predicted price, and the original price was 10, but we predicted that the stock will go 10, I mean 8, and our prediction for Tuesday or the second day is 21. Similarly, 25, 28, and 38. Okay, so this is our data, and let's try to plot the line plot here, right? So plt dot plot days. Okay, days comma original price, and sorry, similarly plt dot plot days comma predicted price. Why I'm using plot and plot again and again? So that is because I want to see 2 lines in this plot. Okay, so maybe plt dot title I will set plot with legends, and plt dot x label. All right, so I have plotted this. Plt dot title is plot with legends, and x label weekdays, y label price. Okay, let me hit enter, and you can see we have 2 lines here, right? So we want to know which line represents original price and which line represents predicted price, right? So this is actually the legends example. What is legend? Of course, right? So legend is nothing but, you might have seen this blue line represents original price and red line represents predicted price, right? Somewhere in your graph or the image, right? So that's what we call legends. Okay, so in order for this legend to work, we need to actually add label to this plot. So label for this plot is equal to original price. Okay, original price, and same way you just copy this and put a comma to this predicted price. So this will be now predicted price, and we want this original price to be represented by the color blue. Okay, color blue, just add b here. Okay, similarly we want this predicted price to be represented by this color red, just add red here. Okay, now after this just add plt.legend and hit enter, and you can see we have the blue line. So this is our blue line, which is the original price of the stock for this particular days, and this is the predicted price of our stock. Okay, so this is the red line. So this is what we call the legends. Now if you want to see the data points here, what you can do is b hyphen o, right? Similarly r hyphen o, shift enter, and you can see the data points here, right? So here we have predicted the proper price, because the original price is also 25 and the predicted price is also 25. So that's why it is intersecting here. Okay, so that's the legends, and we will also see what is the subplots, right? Subplots means the part of this plots. Okay, so this plot has like 2 to 3 subplots. We can divide this plot into 2 3 parts. Okay, so that's why we call it subplots. We will say first subplot is original price. We will see the plot of the original price. It is very simple. plt dot subplot. In this subplot, you pass the number of rows of grid and number of columns and the index. So just add a 3, 1, 1, and then you can plot it like this. plt dot plot. What you want to plot here? Days, maybe I will copy this one. Copy this and I'll paste it here. And you can also copy these 2 things. These 3 things. I'll just put it here. So the title here will be like original prices over time, and this will be days or price, right? And plt dot legend, and hit enter, and you can see this is actually the subplot of this plot. Okay, so this is actually showing you the original price, which is represented in blue color, and we will again copy this. Wait, I'll just copy this, the whole thing, and hit enter, and I'll say second subplot, which is the predicted price. I'll just change the index will be 2, and this will be okay. So I will just copy this, paste it. plt.plot days, predicted price, red color, and with the data point representation O, label predicted price. Okay, and this will be predicted price over time. Okay, and hit enter, and you can see this is represented by red color. Now let's you can also add a subplot to see the difference between original and predicted prices. Let's add this third subplot, which is the difference between original and predicted prices. Okay, just by looking at this data, you can see that the difference between 10 and 8 is 2, right? The difference between 20 and 21 is -1, right? Similarly, difference between 25 and 25 is 0, right? This is what we want to see in the plot. Okay, so how we can do that, right? We want to also calculate the price difference, right? So first of all, we'll say subplot 3, 1, 3, the index is 3, and days. So this will be the price difference, okay, not predicted price. We want to calculate the price difference now. I'll say price difference is equal to, we will use the list comprehension to calculate the difference between original price and the predicted price. So we have two list, right? We have two list, original price and predicted price, right? So just go back here, and I will use for original price comma predicted price O comma P. I'm sorry, just don't put a comma here. O comma P in zip is a method that combines two lists. In our case, we have two lists, which is original price comma predicted price. Okay, original price comma predicted price, and it will return O and P, right? So with the O and P, we will say original price O minus predicted price O minus P. Okay, so this will be the difference, price difference. Okay, so we have the price difference now, and we will pass this here, price difference, and color, we don't want this RO here. Instead, we will say color. Okay, so this is going to generate the bar plot. Okay, not plot. We just want to see the difference, right? So we'll just say plt.bar, and color will be purple. Just add any color. Okay, so the label will be price difference. Okay, so difference between price, original prices. I will add the title, and this one will be the days, and this one will be the price difference. and hit enter. Okay, color is equal to purple. Okay, forgot to add comma. Yes. All right, I'm sorry for that. Now you can see the difference between 10 and 8 is 2, right? You see the 2 here. You start from 0, right? And next, the difference between 20 and 21 is -1. So that's why you see the bar here, right? Just below this 0 price, right? And 3 is nothing. That's because in both the cases, we have predicted it properly, 25, 25. Okay, so this is the difference. But one more thing you see is this, some of these texts are overlapping, right? In that case, what you do is just say plt.tight layout, and it will add some padding between each other. Okay, so that's how you add the subplots. All right, next thing I want to show you is how you can save this figure, right? For example, I want to save this image, right? So what I'll do is I will actually copy this thing. I'll copy this and I'll, okay, before that, I'll just add one markdown saving the figure. I'll paste it here, right? So this will again print this same chart. Okay, and now I want to save this image. As I said in the beginning, this is actually an image, right? So what I'll do is I'll just say plt.savefig. Okay, so in the savefig, just add the output file name, which is example prediction dot png. Okay, and also add dpi is equal to 300 or something. Okay, so this is how you save the image. Okay, just hit enter and go back to your file explorer, and here you can see example prediction.png is created automatically, right? So this is the prediction image. All right, I will close it. And next thing I want to show you is using pandas also we can create the plots and charts. Also we can use numpy to generate the plots. We have also seen that in the previous example, I think. Let me show you. You can see using numpy arrays we have generated the plots, right? So I have some CSV file here. One is tsla.csv. This is the stock data of Tesla stock, and I also have this auto sales data.csv. Okay, so you can just download these two, data set from the resource section of this video. So first of all, I will use this auto sales data.csv and show you how we can use pandas data frame for plotting. Okay, so I will first say loading data with pandas. Okay, loading data with pandas, and how to load the data, right? So you know it already. It is pd.readcsv, right? pd.readcsv. The file name is actually our autosales.csv, right? So I will print it. Oh, I'm sorry, not like this. I will print this data frame and hit enter, and this is how you load the data, right? It has a lot of columns, right? So order number, quantity ordered, and so many things are here. And just want to see df.columns, all these things you already know, right? We have learned it in the pandas section. Okay, so now I want to draw a bar chart with the product with corresponding sales, right? So for example, we have the data here, product line, right? So this product line is something like the categories of the vehicles, right? Motorcycles it has, ships it has, and so many other things also it has. Okay, so the product lines and the sales I want to see. Where is the sales? Okay, so I have the sales here, right? So this is the sales, and this is the product category or the product line. Okay, so what I'll do is I'll actually plot this using bar chart, and I want to pass the category or product line, right? So how we can give it is just simple df of product line. I will just copy this df of product line and comma df of sales, right? We have sales here, and hit enter, and we got this bar chart, right? But one problem here is this motorcycles, ships, train, and these categories are actually overlapping, right? So in that case, you can also rotate these labels here. how to rotate the labels? Yes, it is also very simple. And I will put the comma here because I just don't want to see this object. Okay. And how to rotate the labels? plt.xticks. Okay. Xticks. So xtick will take the rotation. Rotation is equal to 45 degree and comma HA is equal to center. What is HA here? HA is nothing but the horizontal alignment. Okay, so that will be center and the rotation is 45 and hit enter. And you see motorcycle, classic cars, trucks and buses, vintage cars, and corresponding sales also you can see here, right? So similarly, you can, if you want to add the X labels, Y labels, and the titles also, you can use here. Okay, so if you don't want to see this, just add a 1 semicolon and hit enter, and you only see the graph. Okay, so this is how you see the graph using Pandas data frame. And I also have the Tesla dataset, right? So we will make use of this Tesla dataset. I'll say df is equal to pd.read csv again. Cannot read clip and read csv. Read csv. The file name is Tesla tsla.csv and the print df. And here you can see in this Tesla dataset we have date, open price, high, low, close, and adjusted close price, and also we have the trading volume also. So now let's say we want to draw a chart or we want to plot this data set, right? So how we can plot it, right? Usually we always use the close price for prediction or training, right? So this close is very important in terms of financial data. Okay, so that's why I'm going to say plt.plot. Plot is nothing but the line plot. df.close. df.close. Okay, so hit enter and you can see the stock price for every day was like this is nothing but the index of the data, right? It starts from 0 to 3000. I think it has 2956 records, right? It starts from, index is nothing but the days. Okay, so it starts from 0th day and 3000th day or something. Okay, so if you want to add this title, X label, and all that, you can simply add it here. Okay, I'll just add it here, plt.title Tesla, and you can also say Tesla stock prices. So this is the days and this one is the price. Okay, so I think that's enough about the Matplotlib, and this is just a very basic graph. And in the next section, when we are working on the actual stock prediction, we will see such plots very often. Okay, so also those plots will be a little bit complex also. All right, that's all for this video. I hope this helped you get started with Matplotlib. If you have any questions, feel free to ask me in the comments below. Don't forget to like the video and subscribe for more such videos. Thanks for watching, and I'll see you in the next one.